So, I think we have chapel today. So let's just get in and get going. For those of you guys just joining us in the video, I have a couple people absent in period 1 and maybe some others absent other times. We did peek in Google Classroom about the test review from the book is due tomorrow. We are going to go over homework questions a bit today with the understanding that section 4.7, making it match a trig rule, can sometimes be tricky and USEB can kind of throw us off. Kathleen brought up the last 2 homeworks have been hard. They are tricky, hence why we have so much review to do. The bonus test is not due until Thursday, but Adam, you're right. I should probably get that up in Google Classroom just for everyone to see. But I also have your guys' notes open because I did hand out a packet today that we are not finishing before the test. But there are just a couple key ideas in integration as net change that would be helpful, and technically, it's a forever card, but it's not going to be like a forever card. Oh, forever quiz. Did we even talk about that? We haven't, not in period 1. There's a forever quiz tomorrow, I think. It's on the calendar. Well, if you don't know these rules, how are you going to use them, right? And if I don't give accountability. But I'll put 2 bonuses tomorrow. How about that? So you get a 14 out of 10. Ooh, that's just learning points. Huh? No. It's not that many.
Or is it like 35 to 41?
That sounds a little bit better. Because the last one was like 29 to 30 something crazy.
It was like 15 cards.
Yeah, last time was brutal. This time I think we have the ln, the e to the, and that's it. Wait, we only have like 3 cards. We have the ln's, that's number 39, 39, 40, 41. Oh, I am supposed to have this one. 39 to 42. I am supposed to have this one. 39 to 42. So yeah, it's only like 4 cards. 39, 40, 41, 42. 4 cards including this one, and they're all formulas, no quoting. They're all formulas, no quoting. So let's go ahead and throw this one in. I thought it was longer, but it's not. So this one's just going to be forever number 42. Double bonus, one of them is a question, and one of them will be having your cards up to date. Only 4 cards. And I think they should all be online. They're all up to date in these ones. So this is going to be one, forever number 42. So you guys can take a picture of it. You can write it down in your notes. If you get bored at all today, you can be peeking at the packet. Oh, do you need to zoom in? I can yes, please. This is kind of like a, oops, that didn't really help at all, that word. That zoomed out. There we go. It's kind of like getting us close to the OChem tutor guy and like the AP type questions. So this isn't even, I mean, you can make it a section in your notes. It's just not a strict section in our book. So I just called it integrals applied. Like this is just a very AP-ish way to end our more integration chapter. But once again, this huge packet I gave you, it's not due until probably after the weekend, maybe even a little later. For our Friday workday, for those of you guys who didn't hear earlier because I wasn't recording. Friday workday after we take the test on chapter 4B on Thursday. Friday will be a workday on test corrections on chapter 4A, working all together, but also playing with this AP packet, with this formula that we're just going to kind of barely see before the test. And then we'll do AP practice after the test. That way I don't have to give you a full AP test. That would not be fun. Our goal for Thursday is just, can you integrate whatever I give you? At this level. Don't worry, I'm not giving you like the crazy ones you can't integrate. But with USEB and with some trickier rules. And so that's what that forever quiz tomorrow is on, the log rules, those that have to deal with ln, the inverse trig rules, the e to the u, b to the u rules, and then integration is net change. So up here, we've already talked about, to some degree, we've already talked about this motion summary, but like the displacement versus total distance traveled. But there is this extra motion one technically, but instead of just going back and adding it to our motion card, I'm making a whole forever card out of it. I'm making a whole forever card out of it. My whole forever card says, that's great and all. Final position, or your position at a certain time after there's been some change that's occurred because of like a rate. Even though this one's great, the one that's AP-ish, they don't always talk about motion. Actually, they rarely do. They talk about amounts and rates. They talk about amounts and rates. I'm going to go ahead and flip this rubber card because I'm pretty sure I labeled it in a way that's very AP-ish. So you might want to add some of my labels to it. Have your guys' homework out once this is written down so that we can kind of just have a work day on that. If you guys are bored at any point today, I have tons of calculus books. You can be working on your test review problems if you don't have homework questions once we grade. But the things that I labeled up there is this importance of this being not in between time A to time B necessarily, but at time B. For the AP, just some different labeling, that would be helpful. I color coded according to the rubber card up there. This is my final amount. This is my initial amount. And initial could be at time t equals 0, but could also be at some other time t equals a. Don't die, don't die. And this is the change. The definite integral tells us the change that occurs. So how, whatever we're measuring, how much snow is falling, how much gravel is being processed, how many bananas are being picked up, how many tickets are being sold, how many people are entering or in the amusement park. I don't know, 1,012 different things. Final amount equals what you started with plus the change. The change comes from the definite integral of the rate, of the function for rate, of the function for rate. Possibly a better way of writing it, if you want to be very, very, very technical, could also be capital F of B equals capital F of A plus the integral from A to B of little f of x. That is another way of writing it. You want to think about the fundamental theorem of calculus. The final amount equals the initial amount. That looks like crate. Not crate. Rate with a little baby arrow. Anyway, so let's just do a couple of these and then put this away and be like, we'll save this huge packet for later. So if we were to, let's not do trapezoidal sums, that is not on this test. Let's not do area, that is not on this test. Let's go to number 3 and 4 and 5, okay? Let's go to number 3 and 4 and 5. Looking at this formula. But they're multiple choicey ones, and to be honest, maybe they won't take that much work. I don't even care necessarily if you guys make the right match. Let's start with 5 and then work our way backwards. Because what do I see in the multiple choice answers for 5 that are different in 3 and 4? What do I see? Look at number 5. How are the multiple choice answers different? For those of you guys in the video, I believe we're looking at none of these.
5 is like actual.
There you go.
3 and 4 are values.
3 and 4 are values, which means you need to solve, right? But what's number 5?
It's like the before that.
Concept. Did you see it? Yeah, the before. So star number 5, so that's an important one. It's a concept. 3 and 4 you actually have to solve, which is like the nice thing is they're big numbers, which means maybe we can use our calculator. That's nice. But number 5, it's more of a concept. So let's check out number 5. What are they talking about? Amount of. Remember, amount of, it can be anything, but in this problem, what's the amount of? Barrels of oil. Million barrels of oil, right? Million barrels, that's the amount. Okay, what's the amount in number 4, guys? Ton. Tons of something. Pollution?
Yeah.
Tons of pollution. How about number 3? What's the amount? Okay, pause. Are you seeing this? Can you guys underline in 3 and 4 and 5? Underline customers per minute. Underline customers. And I want you to label it amount. Number 4, I want you to underline tons. Do you see where Adam got it? Tons per year. Tons, and I want you to label it amount. And then number 5, million barrels, and label it amount. Unlike any other AP calculus, even though they still can be very tricky, it's still very formulaic. So did you label amount? Okay, so million barrels in number 5, but similarly in number 3 and number 4. So million barrels, that's amount. And then per year. Per year. Doesn't this indicate rate? Right? Miles per hour, feet per second, barrels per year. So where's my rate equation? Right there. Right there. So my amount is million barrels of oil. My rate is this little R guy. And what are they asking? Which of the following expression gives the amount of oil consumed by the country during the time interval? What are they looking for? Are they looking for a final amount, or are they looking for a change in amount? How do you know it's a change? I agree. Because there's bounds. There's an A and a B. They're looking for change. How did it change? What amount occurred over? It's all about what they give you. Over 0 to 10. If they were to say something about at 7, well, that would be different. We would need to think about final amount. But this one, they're just asking for change. So hold on, look at forever card number 42. Which part indicates change? We wrote it in your forever card. Up here, I didn't write it yet, but I can add it.
I'm going to say the first one.
A? Isn't that an at?
No, this one says amount.
We just labeled it. Did you guys not label your forever card the way I did?
No. I was writing the other functions formulas. Yeah, that one.
No, it's not usually, but I felt the pressure of not messing up my whole card.
Have you seen those videos in ski where they drive a circle, they go, they go like, fine.
They go like what?
They like use their whole like wingspan to drive the circle.
I haven't. I need to look that up, huh?
I
I need to put my Sharpie far away from my smart gloves.
So like just don't hit the desk. It's perfect. We're coming down.
So, if that's changed, which of these matches?
I like the D.
Why do I like the D versus the C? Think context. But why?
What about the little?
Yeah, they're trying to trick you. Is this, now, in that one, it's amount prime. F is amount, F prime is the rate, so it's amount prime. But is this one amount prime? No, it is the rate. So if they had like an A for amount being a million barrels, this should be A prime. But if they don't, if they already have the rate, we put it straight in. So I know it's weird, but the idea is all here. Because this is the definite integral. I can't spell integral. I don't know where I was going with that. Initial maybe? Definite integral of the rate. So do what you need to do in studying this card, or I'm looking at this card to know. To find the final amount, we need the initial amount plus the definite integral of the rate. C of the rate, not the rate prime, but the rate. Which is the same thing as the amounts derivative. So it depends on what they give you. If they give you amount, then it needs to be a prime. If they give you a rate, you just plug it straight in. And that's kind of where that OChem tutor at the very beginning of the semester, remember one problem started with amount, the other problem started with rate. You have to be able to go both ways. So then going back to number 4, let's go back to number 3. We're not going to do number 4 just because of time. For number 3, what's this one? Do they want to know an at, or do they want to know an over? Do they want to know the change, or do they want to know a specific amount?
I think it's over.
Why over?
It says over the 60-minute period.
And what's the 60-minute period?
And also there's like a T within a closed
Mm-hmm. So this is also going to be a change. It's also going to be a definite interval. But here's the question, what do we put in? Do we already have rate and so we put it in, or do we have an amount equation that we have to take a derivative of? Why?
Oh, wait, no, just kidding. Just kidding. Don't
Because? So who is this guy? Someone to be derived or someone to be plugged in? If he is the rate, what did we just see? You put it straight in. Oh, because number 5, it was just a matching of how you would solve, like what the expression would be. You see how the multiple choice answers are just like, oh, cool, it matches. This one, I need a number, so am I done yet? No. But guys, what section of our chapter 4b, what section would this be found in? Is it inverse trig? Is it logarithmic stuff? Or is it good old-fashioned U sub? 4.5, 4.6, or 4.7? You only have 3 sections on this test. 6. Nope. What is 5? 5. We started with U sub. So, who's you? Wait a minute, hold on. Don't we know that guy? Isn't it just 12t?
Yep.
Sweet.
Take the 6 out.
But, question, where do I need U sub? Sum and difference. Remember, you don't always have to do U sub to everything. You can do it piece by piece. Yep, and do you remember t over pi or x over 2 or x over 3? How can I rewrite this to make my du easier? You could do quotient rule, bottom d top minus top d bottom. Better know the derivative of pi is 0. Or you can rewrite it as?
Oh, yeah.
So if it's t over 2, I can make it 1/2 t. If it's x over 7, I can make it 1/7 x. Why is that helpful? What's the derivative of this, student?
1/5.
The constant. And that would lead me to, so I can pull out my pi because he's just a constant. I can plug in cosine of u du by substituting in for the dt. My pi du. And then all of a sudden I'm well on my way to solving. I will have 12 times 60 minus 12 times 0, kind of doing this guy in his own separate timeline, plus 6 pi, what's the antiderivative of cosine? Positive or negative sign? Sine of u, who's u?
T over pi.
Why am I going all the way back? Because, Adam, I never went to u bound. So if I want to use my 0 and 60, I got to get back to my, t's. Or I could have done separate work of, hey, who is u of 60? Who is u of 0? And I could have just kept the u and plugged it. Cool. So now I end up with 12 times 60 minus 0 plus 6 pi times sine of 60 over pi minus sine of 0. Ooh, sine of 0 is 0. Forget that. Now, could we have anti-derived this by hand? Yes. However, do you know what sine of 60 over pi is? No. Would you have needed to know? No. Why did I solve it by hand? Because it was a good practice of U sub. But technically, guys, if this would have shown up as a calculator problem, which you're not going to have on the test, it's going to be more of a concept-y one than an actual number one. Because this test is not a big old AP test with lots of word problems and decimal answers. It's more of a, can you do the integral by hand? So did you understand why I did U sub? Great. If this was a non-calculator question, we would box it and be done. But they have nice, pretty numbers. Did you guys see where they said to the nearest whole number? They rounded the decimals because they threw this puppy into their calculators. And so, quick reminder just for AP stuff, in case you guys are starting to solve this at all. You can also do this in your calculadora, calculatrice, your calculator. 12 plus, what was it, 6 cosine of pi over t? No, t over pi. T over pi. My calculator doesn't care if it's a t or if it's an x, as long as you make sure that you tell it what you're doing. Struggle. I don't think I put in all my parentheses. There we go. That's better. So what's my? Oh. Ooh. Am I in degree mode? Because I teach pre-calculus. I'm in degree mode because I teach pre-calculus.
Oh, that's not one of the options.
Yep. Let's try again. 25.
Too good.
But do you see how easy that would be if you had your calculator? You just need to know the formula to plug it into. Like literally, you could have stopped right here. Plug it in, plug it in. I was just making sure that you guys knew how to take the integral. But no, you wouldn't have to know sinus integral. All right, cool kids. Section 4.7. We've talked about integration as net change. We might do another 1 or 2 tomorrow. Might see if the bonus practice test has any. But once again, this is just kind of saying now we're ready to start tackling AP problems. We're going to be working on it Friday. But let's make sure we have the by hand stuff first. Let's make sure we have the non-calculator stuff first. So, section 4.7. I have 6 and 14 and 24 up here. Check it. You might have not rationalized it. The AP would have totally left that square root of 7 down below. It wouldn't have rationalized it. So realize that you might have stopped early. Are you allowed to use the tan -1 notation for inverse? Yeah. You don't have to be writing marking. You can have tan inverse. But Kathleen, just because you were mentioning the struggle of making it match. Is there anything on 6 or 14 or 24 you guys want to ask?
So for 14,
yeah.
You see how the A is 7, and so why did they only choose a positive root 7? Because technically, can it also be like a negative root 7, negative on the outside?
As far as how to choose A?
Yeah, because I put plus or minus, because I thought
you were trying to be as complete as possible.
I feel like the rule.
We didn't get to look at it partially because we didn't have time and partially because I wasn't sure if it would help the majority of the AP kids this year. But technically, all of this arc trig stuff really comes back to a right triangle in many ways. And that A is technically the length of a side.
So it has to be
right. These are all different variations of Pythagorean theorem. A squared plus B squared is tangent. A squared plus B squared is C squared, opposite and adjacent. Square root of U squared, no, A squared minus U squared is a hypotenuse minus a side. That's why it's arcsine, because it's an opposite and a hypotenuse. And like, it's really interesting, the connection, but I feel like you don't really fully appreciate it until BC when you have the rules memorized, you use them, and then you can be like, oh, that's where they came from, and then it sticks. And usually I show it, just this year I didn't, because a time and so positive. But long story short, right triangle, side must be positive. Mathematically, though, you left the door open, and it was a great question to ask. Arcsecant, we had to have that little 2x. 2x and then 3, and then please make sure you're doing your u du. If you don't do your u du, you might have gotten a little bit messed up. Any other questions though on 6 and 14 and 24 that you guys weren't able to see what direction to head, or your u sub? Remember, they're not showing you all your full u du stuff, so it's very possible you're getting stuck. We're okay? Yeah. 14. For 14, in the olden days, we might have taken, like, AKA section 4.6, where we were doing ln. We might have taken this whole thing as a u. You happen to think about? Okay. If we were in section 4.6, we might have said, like, hey, 1 over u, let's just make the whole thing u. Du would have needed, like, a, well, that's derivative of any constant is 0. derivative of u squared, like chain rule, would have been 2 cosine sine. Even though we haven't been doing the CalcCAB way of making it look perfectly, we can still kind of see if we have what we want to cancel out. And you see how there's an extra cosine that's not up here? That's not a good use of. I'm not saying anytime it looks a little different, it's impossible. Because that's enough for me to be like, is there another way to look at this? And the other way to look at it, sadly, I just turned the page, but is to look at those inverse trig, because they have fractions of weird things with squares. And there is one which has a squared plus u squared. Or it could be u squared plus a squared. Addition is commutative. This takes us back to arctan. If I can make it look like that. And so I see a constant. It's not a perfect square, but it is a constant. I see a variable-ish thing. That could be the u. And so if we, if you watch like the video from Friday, because you missed a lot of the practice there, we started saying, hey, can I figure out who the square root of this is? And we're like, yeah, it's ugly. Yeah. Can I figure out the square root of that? Well, yeah, it's cosine. U sub, I have to take u prime, so negative sign. I always say we have a dx, so get that dx alone. And then check it. When we go to plug in, the sign will cancel. I'll have a negative that comes out. We'll put it here. I have a negative that comes out. I would write it like this. The negative can come over here. Oops. Those cancel out. We have our a squared, we have our u squared, so we're able to go straight to this answer, which says, okay, you have that negative, so it's a negative, but now it's the normal formula of 1 over a arctan of u over a plus c. So inverse trig is like this hidden, because there's no trig right here, no cosines, no sines, no tangents. But because of what I was just trying to explain to Adam, there's this whole right triangle relationship that can get me to trig. We're just going to memorize those 3 rules really good so that if it's not working with normal u sub, be like, wait, does it fit? It does fit. Is that cool? But way more examples on Friday if you have time to go check out. As far as trying to make it match. Number 40. Number 40 was hidden. Was super hidden because you needed to complete the square. Because if you were trying to make it match with arc sine, if you saw that there was something out in front, maybe you were thinking of like, ooh, wait a minute. Sorry, arcsecant. Something in front. I mean, you could have said, like, I know that u is x minus 1, but he's not here, so how do I make him be there? And that's what we talked about a little bit on Friday. Just a quick reminder, since some of you complete the square is not your best friend. Hi, buddy. I need you to work. Thank you. The integral of 1 over u. If u is x minus 1, du is just 1 dx, so I can just go ahead and make that substitution. But I need to go ahead and figure out what to do with this. And so remember, complete the square, I put in what I want, and I have to offset it by the opposite. And so what's 1/2 of negative 2? Negative 1. Squaring it. I need to do a plus 1 and a minus 1, and then I get my complete the square of x minus 1 squared. They just jumped there. I'm just showing you how to complete the square. So then you have your 1 over u squared minus a is just 1, du, and so you have your 1 over a, which is just 1. Arcsecant of, remember, absolute value. We added that into our forever card, right, guys? Or was that just grade 6? Did I not get it for you guys? The absolute value of the secant formula?
Grade 6 ahead of us now? What happened?
I don't know. Oh, we didn't. I saw it when I was making our forever card. Or I was making your forever card. We need to throw a little absolute value up top.
Just for that one?
Just for that one.
Why?
Because arcsecant usually has an absolute value right here.
Oh.
But since we are dealing with how do I explain it?
Is this like another like
it's kind of having to do with that whole triangle relationship again.
Okay.
It's kind of having to do with that triangle relationship again. But you can also think of a way of remembering it is arcsecant always has the absolute value here in the derivative formula. And so we need it somewhere. It's not going to show up in the beginning, so we need to put it at the end. That's a silly way of remembering it, but it works. So if some of you guys got confused by the absolute value, it is a part of the formula that, for some reason, I just need to get back to my master notes and change. I keep on forgetting. Okay. Oh, sorry. I'm like randomly in your notes, and we should be in your homework. Were there any more evens that you guys had? Okay. 74, final answer was D.
I saw the first one and no, so.
This one you would have had to pull out a negative and then complete the square.
Wait, let's see if I. Miss, do you have a question?
U is x over 2, which is 1/2 x. Yeah.
For the first one, I pulled out a 2, and then I did like an ln thing. Can't you?
How could you do ln though? If anything, this would be u to the negative 1/2 power.
U square root of all of it.
But du is a nasty 1 over 2 square root.
Oh, I'm just looking at u. That's
Yeah.
why.
Yeah, no, du gets nasty. Now, hold on. Number 3, though, is a good old-fashioned u sub. Because u is equal to x plus 1, I can make it u to the negative 1/2 power, pulling out the pi over 2. And then I can go ahead and do u to the negative 1/2 power du after doing all that jazz, and it ends up being u to the 1/2 power over 1/2 or times 2. 3 is a good old-fashioned u sub. 2 is a good old-fashioned u sub. Section 4.5, section 4.5, but this one is definitely section 4.7. I need to complete the square. Okay, Kathleen, I know that you mentioned, I don't have tons of time, but I know that you mentioned that there was just some that were hard to see. Were there any odds that you wanted to peek at real fast? If you guys are curious about your completing the square, that's what you would have wanted to do. To complete it. 17? Because 5 over 2 gets squared to be 25 over 4. Because to complete the square, you need to have your x squared be first, so I pulled out a negative to make it ordered correctly for complete the square.
Is the negative allowed to be inside because like the bounds don't go beyond like what would make it negative? Like inside the square root.
Yeah, I can't pull the negative out because that's an imaginary number. So I have to leave it in.
Don't make it imaginary, right? The bounds are okay.
Well, true, but also I need my a squared minus u squared for arc sine. Yeah. So actually I need that minus or else I can't use my rule anyway.
Oh, you're right.
So it's going to be smaller than 25/4. Number 17. It's in the inverse trig section, but some of you might have been like, but that looks kind of like I should just make the whole bottom a u. If you guys are thinking about section 4.6, like 1 over u du. Of course, my computer doesn't work when I need it to. That's just my life. But if you guys notice, if u is x squared plus 1, what would du be? Yeah, over 2x, which is great for this guy, but is it good for the 3?
No.
Oh, struggle. Sorry. Computers doesn't work. Okay, we could split this up and be x over x squared plus 1. And then actually negative 3 over 1 over x squared plus 1. Kathleen, this is like a prime tangent inverse because I have 1 over u squared plus a squared. This one is a prime. Let's head towards an ln of 1 over u because now that I have my x alone up top, it's going to be perfect when I go plug this in. So I'm going to end up with a 1 over u with a 1/2 coming out and a du, which I can go to ln. Whereas this one I'm going to have a tangent inverse of u over a with no need for a 1 over a because it's just plus 1. So I'm going to have a 1/2 ln of this dude minus the 3 tangent inverse. I can still split up. That guy's a great arctangent because it's constant over. That guy's a great u sub because it's variable.
Got it.
You guys are just playing tonight. I see it. 20 seconds. Thanks for the extra 20 seconds. technology worked, maybe we would have been out in time. But it is chapel day, so I'm going to let you guys go. Play with the test review.